Okay, I can share my screen. Okay, semua nampak ya? Dapat nampak lihat. Okay, so we are in chapter 6. We continue last week about the molecular weight of the polymer. Okay, so we already know what is the polymer, consists of the monomer and then they are linked small repeat unit ni to form the core as a polymer. So they have a chemical structure of monomer unit, 3D structure, different monomer unit. So for example, kita ada yang very strong and tough, Kevlar, yang naturally ialah the DNA, the polymer. So ini semua adalah terdiri daripada the chain, polymer chain. Okay, molecular chain. Okay, so now we are in molecular weight. So about the polymer, the molecular weight of the polymer is the way of describing how long the polymer chain are. So dia adalah untuk kita mendescribe, menerangkan menerangkan berapa panjang polymer chain. So itu akan menentukan berat polymer itu. So each monomer has a molecular weight. So dipanggil sebagai formula weight. Adding the monomers together, so dia akan menyebabkan polymer tu akan increases in their molecular weight. So the longer the chain, so we add. Ni dia satu unit kita campur. Kita add dia, so the longer the chain, the higher will be the molecular weight. Of the individual chain. Tapi kalau kita tengok, kita talking
Sorry, doktor.
hello?
Ya,
Cepat
doktor.
lah. Saya tadi hilang
Hilang doktor.
Hello? Hello?
Ya doktor, dengar doktor.
Dengar doktor.
Okay. Alright. Lost connection. Internet tak stable Okay, so saya share screen. Alright. So when we talk about the molecular weight in terms of polymer, actually we are talking about the length of individual. Tapi dalam production of polymer ni dia ada berbagai range length dia. So we actually discuss the adalah the average molecular weight of the material. So this average is found by measuring sample of the material as it is produced. So there are two different categories of molecular weight. Okay, there are two category of measuring the used to categorize dia punya molecular weight average, iaitu ialah the number average molecular weight. The symbol is Mn, and then the second one is the weight average molecular weight of the polymer, Mw. So this is about the number and this is about the weight. Okay, so kita selalu nampakkan macam NI, MI, pernah macam tu. So another important aspect of polymer molecular weight distribution is the shape of the curve. Satu lagi ialah bentuk curve weight molecular weight distribution. Okay, so sample of synthetic polymer always contain polymer chain with a range of chain length. One of the way to describe the length of the polymer chain in terms of average molecular weight is the average of all the chain length in the sample. So kita kena calculate ialah the average of all chain length in the polymer sample. Bagaimanapun different sample of the same polymer, dia boleh mempunyai the same average chain length but very different distribution of chain length depending on the method of the polymerization. So in the polymer science, the molecular weight distribution is very important lah. So molecular weight distribution, MWD, singkatan dia iaitu molecular weight distribution of polymer. Dia ialah is a molar mass distribution which describe the relationship between the number of mole and each polymer and the molar mass of that species. So dia adalah kita ada dia punya mana dia punya. So normally dia kalau mana saya punya mouse ni. Okay, so kita akan normally N lah dia akan ada N1, N2, N3 macam tu. So this is the number of molecule that polymer chain tu, and then dia ada juga melibatkan the mass. So number of mole for each polymer and the molar mass. So kalau mass ni normally represent by M lah. So itu ada. Kalau molecule 1, M2, M3 and sebagainya lah. Dia ada sama juga dengan number, relationship dengan number and the between the number of molecules ni, M1, N2, N3 and so on lah. So the molecular weight distribution ni M yang tadi tu, the number average molecular weight. Okay, so dia adalah kita boleh calculate melalui melalui number of molar for each polymer kali dengan dia punya mass, molar mass dia, berat molar mass dia, and then kita bagi dengan, dia ada banyak kan, so untuk setiap tu kita kira bagi dengan jumlah bilangan nombor number of moles tu. So dia akan jadi mn sama dengan jumlah lah, summation. Okay, so it's also important factor to be considered during processing juga. So penting untuk kita determine characteristic and properties of the polymer, kerana dia juga penting factor to be considered during processing as it affect flow properties, glass transition temperature and also the melting behavior of the polymer. So this is the molecular weight distribution curve. Okay, this is the molecular weight distribution curve. So if you can see here ialah dia punya bentuk curve dia. Okay, so this is the distribution. So the curve kita panggil sebagai molecular weight distribution curve, MWD. So the average molecular weight ni kita determine by summing or the weight of the chain and then kita divide by the total number of chain. Total number of chain yang N, maknanya kalau kita ada banyak N1, N2, N3 yang macam tu jumlah dia. Okay, so kita akan dapat curve macam ni. So the curve ialah the distribution curve. Okay, taburan. So kita akan calculate lah untuk setiap ni. Untuk setiap ni. Okay, dia berbeza-beza dia punya ni. Alright. So the distribution of the molecular weight also has a large effect on how the material will be processed and also the properties. Okay, for example kat sini kita ada dua distribution curve. Okay, so yang ni ialah the broad one, lagi lebar, yang ni ialah a bit narrow. So a broader or wider spec ni, okay, distribution may make the materials unsuitable for processing like injection molding, but the better suited for the process like extrusion, blow molding or thermoforming yang white ni. Okay, so dia maknanya suhu dia, ranging suhu dia sangat broad, sangat lebar juga. Ya, kerana dia ada terdiri daripada banyak yang pendek-pendek dan banyak yang panjang-panjang. So dia pelbagai itu tinggi. So, that's why the distribution curve dia adalah lebih gemuk, lebih lebar. So, untuk yang slim, dia adalah lebih sesuai untuk material yang mempunyai rantaian polimer yang almost close to each other. For injection molding grade material, narrow distribution adalah lebih sesuai kerana dia akan melt pada suhu yang sama. So easy for them to liquidize and flow. When the distribution is narrow, the polymer chain will melt and flow at around the same temperature. Sebab kita tahu kan dalam injection molding process, we have to melt the resin and then the resin must be able to be fluid enough to be inject into the mold at high speed. Okay, so kalau dia terlalu likat, it's very difficult. Okay, untuk kita inject. Pekat means that kalau taburan dia lebar tadi, so dia ada yang mungkin perlukan yang rantai yang pendek maybe perlukan suhu yang lebih rendah, rantai yang tinggi maybe perlukan suhu yang lebih tinggi. So the broad of the temperature range juga akan mempengaruhi material itu untuk flow. So the longer the chain, the higher will be the viscosity or resistant to flow. So kalau dia narrow, very narrow, so each of the polymer chain tadi perlukan suhu yang hampir sama untuk kita set dia supaya dia melt and be able to flow and inject into the mold. Good. Average molecular weight and measurement, different average values can be defined depending on the statistical method. Okay. Kalau number of average molecular weight, Mn, defined as a total weight of polymer divided by the total weight of the molecule. So yang ni lah kalau kita ada tadi several number of molecule polymer tadi, chain dia N1, N2 and N3 and so on. Okay, so kita ada macam ni Ni lah. So N1, N2, Ni lah normally kita represent, and then we have also the the mass of the molecule, the mass of the molecular weight. So kita ada M lah, represent by M. So kita ada M1, M2, M3 and so on. So to measure the average molecular weight Mn, so it's the summation of the total ataupun summation of the Ni kali dengan Mi bahagi dengan jumlah of Ni. Okay. So di mana Ni ini number of mole, Mi molar mass, Wi weight of the polymer. So kita dapat some Mn, iaitu number average of molecular weight. Okay, so Mn of a polymer can be determined, kita boleh measure dia by using the gel permeation, chromatography, ataupun kita boleh guna viscometry atau qualitative method such as vapor pressure oscillometry and group determination or proton and NMR. So beside that, we also have the average molecular weight, MW. Okay, average molecular weight. So kita ada number average molecular weight dan kita ada weight average molecular weight. So the weight is W lah. The MW is way of describing the molecular weight of polymer. So it's an average weight of different size of polymer molecule. So kita determine dia, kita define dia. So sama macam tadi juga the second type of weight, average molecular weight ni, kita ada weight dia, weight of the species of the polymer tu, kita ada let's say W1, W2, W3. Okay, W is weight. Okay, so the normally kita represent by Wi lah. Okay, and then kita ada dan juga kita ada molecular weight of that species iaitu M, M1, M2, M3. So kita akan buat dia sebagai average molecular weight is the summation of the Wi, Mi, okay, bahagi dengan summation of Wi. So where is Ni is the number of molecule of the molecular weight Mi. So MW can be determined, dia boleh guna light scattering ataupun X-ray scattering to measure the MW. So MW also related to the fractional monomer conservation, iaitu integral polymerization, okay, where MO is the molecular weight of the repeating unit. So selain daripada itu, kita juga ada Z average molecular weight. Okay, so they define as the Z average molecular weight summation of NI-MI kuasa 3 divide by summation of NI-MI kuasa 2. So ni by using this formula we can calculate lah. Okay. Okay, next a polydispersity index. The polydispersity index ni ialah kita measure of the distribution of molecular mass in a given polymer sample. So polydispersity index is the weight average molecular weight. Kita divide by the number average molecular weight. So it's indicate the distribution of individual molecular mass in batch of polymer and give an indication just how narrow a distribution is. Okay, so jumlah average berat molecule dibahagi dengan number, average number of berat molecule. Okay, so this is a typical distribution curve lah untuk average molecule values of related to each of the following. Okay, so kita akan ada number of molecule and this is the molecular weight. So this is average molecular weight. Okay, average molecular weight. Viscosity average molecular weight, number average molecular weight, dia punya yang tengah ni. Okay, dan macam ni, number average molecular weight Mn dan average weight molecular weight Mw. So this is the curve that kita panggil sebagai, the curve is called as the molecular weight distribution curve. Okay. So how does this molecular, kenapa molecular weight penting? How does the molecular weight distribution penting? Because it affect the polymer properties. They affect polymer properties. So normally a higher molecular weight akan increases, for example, tinggi molecular weight ni, a high molecular weight akan increases the impact resistance of the material. Boleh boleh dengar suara saya lagi kan? Masih ada kan you all?
Masih ada.
Okay, saya tak terkeluar. Okay, so the effect of molecular weight, NW, on the polymer properties, kita tengok. So it's very important to know because this average molecular weight or molecular weight distribution ni, dia effect kepada viscosity, dia properties lah. For example, high molecular weight of polymer normally having high viscosity, sebab bila berat molekul dia tinggi, maknanya rantai polymer tu panjang, so payahlah dia untuk kita disturb dia. So dia very high viscosity, low density and more amorphous portions. So untuk low molecular weight, low viscosity, high density and more crystalline portion. So molecular weight distribution affect the transitions in polymer and softening behavior of the polymer. So it's very important, this element during the processing of the polymer lah. So broad molecular weight distribution contain more shorter chain. So therefore dia, sebab bila broad maknanya dia banyak juga yang pendek dan ada yang panjang. Kalau narrow tu jumlah rantai polymer dia almost very close to each other. So yang ni broad, so they contain more shorter polymer chain. So this shorter polymer chain tadi akan easily slide to pass each other because of dia ada kurang dia punya entanglement, kurang kurang kusut from one to another. Rambut pendek dengan rambut panjang lah, you bayangkan macam tu. Kalau pendek tu easily untuk kita sikat dia atau kita manage dia. So kalau dia panjang, dia akan entangle, so it's very difficult. So contain more short-term polymer chain, so which is easy untuk slide to pass each other, so therefore it's less entanglement lah untuk yang broad the molecular weight distribution. So now effect of molecular weight on the polymer properties. Many polymer properties of interest seperti TG, glass sensing temperature, the modulus is the elasticity, the elastic properties of the polymer, the strength, okay, follow a pattern which increasing the molecular weight. Okay, for example kat sini physical properties, example modulus, strength, TG semua. So small molecule, kalau kategori oligomer, molecular size the polymer. So the physical properties dia adalah meningkat. Small molecule have a small molecule have small values. Then there is a sharp rise in the properties as the chain grow to intermediate size, iaitu oligomer, and then the properties level of as the chain become long enough to be true polymer. So dia dah jadi polymer. Alright. So effect of molecular weight on the properties ni when making polymer. Okay, the goal is to make a material with ideal properties, of course lah. Okay, so the longer the molecule or the higher the molecular weight, the higher will be the entanglement force. So macam dia kata longer hair is harder to get entangled than the shorter hair. Kalau macam ni tak entangle langsung lah, tak berkait pun. Okay, so increasing the molecular weight of material akan increases many of the properties of the material by increasing the entanglement of the molecules. So a higher molecular weight akan increases the chemical resistance. Okay, so lagi better dia punya resistance towards chemical attack. So it take more damage to the main chain of the molecule before it will affect the strength of the material. Kalau dia rantai dia panjang. Okay, so the big loophole to this is if you have a chemical that is very similar to the chemical makeup of the main chain, it will dissolve it much more easier. Sebab dia dalam kimia ni light dissolve light lah, dia akan attract tu yang mudah. So the higher the molecular weight, dia akan increases how far the material can stretch before rupturing, or itu bergantung pada dia punya ductility. So the higher degree of entanglement allow the material to be pulled further before chain break. So dia lebih strong lah sebab dia ambil dia need the more energy. Okay, so the higher the molecular weight akan increases the ductility. Okay, candle and polyethylene have basically the same molecular structure, but the chain length of the candle is just much shorter as compared to that PE. If you bend a bar of PE in a half, it will bend. Okay, tapi kalau candle, it will fracture. Okay. Okay, so in the cases of impact, kita kenakan hantaman, increases the impact resistance of the material lah kalau high molecular weight. So the higher the degree of entanglement means that in order to rupture, more polymer bond need to be broken. Okay, so this means that the polymer can absorb more energy before fail. So the higher the molecular weight, next is increases the weather resistance of the material. Okay, so some type of reasoning behind the increase in chemical resistance, the chain are longer, lebih panjang rantai polimer dia. Kalau berat molekul dia tinggi, maknanya rantai dia panjang, so that they can withstand more damage before the mechanical properties will start to diminish. Okay, so dia juga increases the viscosity of the material, maknanya. So it's harder to process the materials using conventional method. The longer the chain, the harder is to get them to flow. Okay, so processor want material that will flow easily in order to form complex geometry during the processing of polymer, but they can affect the properties of material used. Many times it's turned out to be trade-off lah. Dia akan either you dapat ni atau you lost ni. Okay, so many times it's turned out to be a trade-off between the required properties and processability of the material. So saya berhenti kat sini dulu. Kita jumpa lagi nanti. Kita jumpa lagi nanti, dan nanti saya akan share attendance link. Boleh isi attendance link nanti. Okay, sampai jumpa lagi. Terima kasih for attending lecture today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Doktor.
Thank you, Doktor.